The world's a pretty big place. With our busy lives, no reasonable person can be expected to keep up with the biggest headlines each week, so I'm here to do it for you. This is Tony Pearson coming to you on behalf of WHIP with this week's Big Picture. I don't know how it was elsewhere, but this past week, moving into December here in Philadelphia, was a bit strange, weather-wise. Ever since I was little, I remember being really excited for this time because I like the winter, I like the cold, I like the snow, and late November is when you start to get some of that snow, some of that cold weather. This past week has, of course, been nothing like that. It's been especially warm. Some days it got into the 60s, and we got a lot of rain, actually, until the end of the week when it started to get back to about what we can expect. This is relevant, though, to what we're going to talk about today, because today I'm really only going to go into two big stories. They're both related, and they're both about something that affects all of us, whether we choose to acknowledge it or not. Today, I'm going to be talking about climate change. Now, climate change is relevant for a bunch of other reasons. It's not just recent changes in weather that accompany it. It was just over, I believe, this past year that atmospheric CO2 levels jumped over 400 parts per million, which is very, very high. A huge topic on the campaign in the past year, one that honestly I wish I would have touched on more, was climate change, something which up until recently Trump vehemently denied, and now he's gotten more, he acknowledges that it could be something. We'll see where his stance lands in the end on that. But in any case, a lot of people still don't believe that climate change is happening. For a lot of people, climate change is a lot like politics or even religion, and you either believe in it or you don't. I'm here today to talk about how that's not how this works. It's science. It's not often that I will say someone's beliefs are wrong or that they're even not okay. I believe that perspective is something very important and that it can change the way people see things and believe in things in ways that I honestly have no place saying what's right or wrong. But this isn't like that. This is one of those few areas where I do think there's a very clear right and wrong. Because climate change isn't something that you just believe in. The fact that this is happening is something that's backed up by science, by decades of research and experimentation. Science isn't something that you can believe in when it benefits your ideals and not believe in when it doesn't. The same science that allows your iPhone or computer or whatever you're listening to me on to work is the same science that's been used to show that this stuff is happening. The same science that might save your loved ones when they're in the hospital. The same science that you rely on to take your medicine to deal with, whatever problems you have that you may or may not need to take medicine for. The same science that powers your car, the same science that got us to the moon and showed us that the earth isn't flat, is the same science that shows us climate change is occurring. I don't know why that part is political, because it shouldn't be political. Now, there is a part of climate change that is debatable, that is political. We'll talk about that at the end. That part is, what should we do about it? And there are a bunch of options and differing views about what to do about it. There are things I agree with and things I don't. But in that case, once again, I'm not going to say what is right or wrong because I don't have all the answers, obviously. But the fact that this is happening really isn't debatable anymore. So before we get to our news stories, I'm not going to say all that without going into further detail. I'm actually going to explain to you guys how climate change works, to give you a crash course on it. So buckle up and get ready to discuss the science behind climate change. First things first, and this is what gets most people, you have to understand that there is a fundamental difference between climate and weather. Weather is what happens between days and weeks wherever you are. It refers to atmospheric conditions over short periods of time. When you're packing for a vacation, you check the weather to know how to pack. And it makes sense. Weather varies wildly depending on where you are in the globe and what time of year it is. Even here in Pennsylvania, I've seen it get as high as 100 degrees during the summer, and I've seen it drop as low as -5 or 10 degrees during the winter. Because these changes so fast, weather is usually what gets the biggest reaction out of people. A big hurricane or a big snowstorm or a tornado or hail or something like that usually gets people to act pretty quick. It's also the reason why a lot of people point to snow and say, look, global warming isn't happening because look at all this snow. But that brings us to why a lot of people, myself included, call it climate change now. I do believe that's more accurate of a title because climate change and what global warming refers to It's not about weather, it's about climate. Now, climate refers to characteristic atmospheric conditions over a long period of time. We're talking years or decades. Climates are why you get areas like deserts. You might get rain, you might even get a little bit of snow in a desert, but over a long period of time, that area is dry and arid and whatever else it is. The truth is, every part of the globe has its own climate. Changes to that climate happen much more slowly, and they have much more intricate and complicated effects on the environment. So, at this point, we get into one of the huge driving factors in what a climate in a given area is like: temperature. Now, that's a whole other area of science as to why temperature makes these huge changes in the atmosphere that lead to different climates. But if you want to see what these kinds of differences can make, just compare areas on the equator to, say, Canada. They're different, so temperature is important. So it makes sense that the way the planet retains its heat is also important. Now, we get all of our energy from the sun. The sun shines on the earth, and a lot of that light is reflected back. A lot of it is absorbed right into the surface. And the thing that kind of stands right in the middle of all that is the Earth's atmosphere. And the atmosphere can do the same thing. It can absorb heat, it can reflect it, it can trap it, etc. This brings us to greenhouse gases. Now, greenhouse gases are actually very important. What these gases do is they essentially cause light that hits the Earth to bounce around inside the atmosphere for a while and stick around and keep us warm. If we didn't have greenhouse gases, the parts of the planet that weren't in direct sunlight would be really, really cold. In fact, without greenhouse gases, our planet probably wouldn't be livable at all. Now, there are a bunch of these gases in our atmosphere. The three most, potent ones being methane, carbon dioxide, and, believe it or not, water vapor. In fact, water vapor is the strongest greenhouse gas that we've got. What really separates these greenhouse gases, however, is something called their residence time. Residence time is how long a gas will stay in the atmosphere before it dissipates or goes away, I guess. For water vapor, this happens very quickly. The Earth has a water cycle that circulates it around quite efficiently. Methane, which is also a very potent greenhouse gas, also has a comparatively short residence time, about 10 years to be precise. Carbon dioxide is different. While carbon dioxide is less potent than both methane and water vapor, its residence time is from 50 to 200 plus years, which means that when you add carbon dioxide to the atmosphere, whatever effects it has on the atmosphere will continue to happen for about 200 years before there's even a chance that you can start to go in the other direction, or at least naturally. So these gases have a whole lot to do with the way light and heat are absorbed by the Earth and kept here. Now, getting back into climate, our climate also has natural existing cycles. Most of the time, Earth is actually very cold, in a sort of ice age. And every 100,000 years or so, things get warm for a while, a few thousand years, and then things get cold again. These cycles are natural, they exist, and they happen very slowly. And that is what makes modern, man-made climate change different. We're seeing effects much, much faster. We're seeing changes in climate and temperature over the course of a few hundred years at best, although we've been seeing these changes every 10 or so years. It's accelerating. Now, this is pretty freaky, and scientists have been looking at this for a long time because they've wanted to find out, okay, is this normal? And looking at the data, it appears not to be. There are a bunch of things that naturally change and can increase the Earth's temperature over time. But when you look at that data, the past few hundred years shouldn't see changes as big as we've seen. The changes we should be seeing are very slight. And that makes sense. This kind of stuff is supposed to happen over thousands of years. Scientists have looked at orbital changes of the Earth, changes in the way the sun produces energy, changes in volcanic activity on Earth, just to name a few. And when you graph these all together, they have nothing to do with the way temperature's been increasing recently, which, by the way, it's been increasing a lot recently, but we'll talk about that more later. The big difference happens when scientists start to look at issues related to human beings. Scientists have looked at things like land use and found that they have little to no impact on the global temperature. They've also looked at levels of ozone in the atmosphere. And while it's changed a bit, that too seems to have little effect right now on the Earth's temperature. The same can be said for aerosols. The big change happens when you graph greenhouse gases to recent changes in global temperature. There is a very strong correlation between man-made greenhouse gases and the increase in global temperature. When you graph these with all of the other human factors, you can see that these human factors and the global temperature actually line up very, very well. When you then go and graph these human factors with the natural factors, they line up almost perfectly. Now, these conclusions are being made with data that's been gathered over the course of literally hundreds of years. And it's not just a little bit of data, it's an overwhelming amount of data. Bloomberg has a fantastic visual representation of this, which I've listed in the description of this podcast. I mean, it's also great because it has all of these sources cited with it. But the point's clear. The Earth is heating up right now, and there's very little question as to what is causing that change to happen. It's greenhouse gases, and we do make a lot of them. And the scary part is that CO2, which is the greenhouse gas we produce a whole lot of, is going to stick around for a while. Like I said, if you want to see a great visual representation of this, check out that Bloomberg link. And if you want to see my sources, also check out that Bloomberg link. But anyway, the important part is, what will this do to us? Well, global changes in temperature, even very slight ones, can have huge impacts on a lot of other things. The big ones we're going to talk about are, of course, rising sea level and changes to weather. As temperatures increase, a lot of the ice on the planet will melt, because where it is right now, we're in kind of a sweet spot where a lot of that stuff gets to stick around and be really old and icy because the temperature's just right. You change it just a little bit and those things start to go away. That ice starts to melt. Now, this is actually a problem for two reasons. One, there's a lot of ice on our poles, enough that when it melts, sea levels can rise quite a bit. In fact, a lot of current models suggest that sea level may rise as high as 6 feet by the end of the century. This would submerge many island nations and coastal states and cities around the globe. Millions and millions and millions of people would find their homes underwater. But it also has another effect. You see, melting ice causes a bit of a positive feedback loop. The bright icy material actually reflects light back into space. It actually helps to cool the globe. As we lose this ice, less light is being reflected back into space, and it's actually speeding up the heating of the Earth. This is called the albedo effect, and it's something that is scientifically very well understood. It's the reason why dark cars get hotter in the summer. Additionally, as climate changes, weather will change too. Like I said, the effects of temperature on weather are complicated, and I can definitely get into them on another episode if there's interest. Needless to say, weather will change as climate and temperature changes. We've already seen it. There's a reason why the past few winters have been warmer in some areas and cooler than in others. Storms like hurricanes have been getting stronger. None of this stuff is coincidence. In the end, though, the point is, based on the evidence that scientists have analyzed, it is extremely likely that human activity, specifically the increase of greenhouse gases in our atmosphere, is behind the extremely rapid climate change we're experiencing right now, which is definitely not normal. And when I say it is extremely likely, I don't mean like, oh, we're pretty sure. I mean, it's extremely likely in the same way that it's extremely likely that the Earth orbits the sun, and it's extremely likely that the Earth is not flat. Like I said at the beginning of this podcast, this isn't opinion, this isn't belief, this is science. And 21st century science is pretty damn good. It's the reason we've got computers that fit in our pockets. That same science is telling us that the changes being made right now will take hundreds, if not thousands of years to undo. Ignoring this problem will not make it go away. In fact, climate change is listed as one of the foremost threats to our nation by the Pentagon, and this is for a good reason. Terroristic organizations and nuclear weapon-wielding nations like Russia may pose a threat, but they can be bargained with. You can talk to them. Climate change does not work like that. The best you can do is prevent it, and failing that, you can try to delay its effects. But left unchecked, it will kill indiscriminately across the globe, making cities uninhabitable and changing society as we know it. It can't be bargained with. You can't talk to it. This is something that is going to happen if we continue to do the things that make it happen. It's a big deal. There's a reason why there are a lot of governments that are taking it very seriously right now, including parts of our own. This brings us to today's news. A new report on climate change released this week has demonstrated that we are already past the point of no return as far as climate change is concerned, and that if we want to save ourselves, we need to begin efforts immediately to dampen its effects. The report, published in the Nature journal using data from 49 field experiments over the last 20 years, shows that huge amounts of CO2 are stored in soil around the world. More specifically, that 55 billion tons of CO2 will be emitted into the atmosphere by 2050. This is CO2 that we haven't taken into account before. It's a big deal. This is the result of a positive feedback loop, kind of like the one that we already mentioned. Slight increases in global temperature have made organisms within the soil on Earth more active, causing them to release more CO2, like most living things do, and heating the atmosphere more, becoming more active, etc. This process has already begun. It's too late to stop. We may be what started this process, but now that it's going, now that it's hot enough to continue, it doesn't need us. This is very concerning, and it brings us to our second story from this past week. This past week, multiple senior military figures from around the globe made official statements on the dangers that climate changes pose to our society. Brigadier General Stephen Cheney of the U.S. Department of State's Foreign Affairs was one of them, and I do believe he hit the nail right on the head in an interview released by The Guardian on December 1st. Cheney is quoted saying, "Climate change could lead to a humanitarian crisis of epic proportion. We're already seeing migration of large numbers of people around the world because of food scarcity, water insecurity, and extreme weather, and this is set to become the new normal. Climate change impacts are also acting as an accelerant of instability in parts of the world on Europe's doorstep, including the Middle East and Africa. There are direct links to climate change in the Arab Spring, the war in Syria, and the Boko Haram terrorist insurgency in sub-Saharan Africa." End quote. This all really does make sense when you think about it. With rising sea levels, about 2 million U.S. coastal homes will be underwater by 2100. That's a low estimate given the new information mentioned earlier. Entire countries, such as the island nation of Kiribati, could be submerged far sooner, within our lifetimes easily, and especially within mine, as someone who's 20. Can you imagine the refugee crisis when large swaths of inhabitable land around the globe just disappear? When changes in weather cause food shortages unlike any the modern world has seen? If you think things are bad now, and I really hate being all doom and gloom with you guys, just wait. These military types are concerned for good reason. Now, I made today's episode special and all about climate change because it really is a big deal, and because unlike how I feel these things usually go, I feel like scientists usually make things seem worse than they are, and then they turn out not to be that bad. In this case, it seems to be the opposite. I remember being 10 in elementary school, being taught about this stuff, and the idea was that we had to make changes, do things better for the environment, because our children and our children's children were at risk. Recent developments are starting to show that these changes are happening now. Not that that should make a difference, but that we are seeing these changes now. 10 years ago, we were talking about this stuff in school. That decade ended up being the hottest in history, and this one is lining up to be the new hottest in history. Changes in climate are already translating over to changes in weather. The past 2 winters have been the warmest I can remember. And in some parts of the globe, they experience the coldest winters. Because remember, this isn't just about heat in all areas. I mean, it is about the globe warming as a whole. But this can start to make certain parts of the globe freeze that wouldn't otherwise. I don't know if it's just because I'm younger and these changes are more obvious to me, but these changes are already starting. And the changes that we're experiencing right now are so minor compared to the ones that we have in store. And yet they already hurt. Hurricanes are getting stronger. Other storms are becoming more frequent. This stuff is already happening. I didn't think I was going to have to think about this like this. For the longest time, I wanted kids. And now, I'm going to be completely honest, I weigh this stuff very heavily when I look at my future. Speaking as someone who has the majority of their life ahead of them, I don't know if I want to have kids, knowing that some of the biggest crises and mass deaths and destruction of society are ahead of us, probably within my lifetime and definitely within my children's. And the worst part about this is we knew it was coming. We knew it was coming. People started talking about this stuff. People started talking about this stuff more than 50 years ago. And in like the past 25 years, we got really good at looking into it. In the past, looking at my lifetime, what I can remember, in like the past 15 years, we got really certain of it. And within the past 5, it's essentially fact. Parts of it that at one point were arguable, Are humans causing it? Maybe 20 years ago that was arguable. Now we have our answers. Yes, it looks like humans are causing it. Honestly, it's disappointing. It's really sad. A disaster, a travesty, far larger and more destructive than the Holocaust or anything we've ever done before, is right on the doorstep. And yet there are still large numbers of people who are in power, who won't even acknowledge that it's happening. And this is science. That's why I chose to do this episode today, because the news about this new unaccounted for source of carbon dioxide came out, and then the statements from a number of military generals, not just in the US, but around the world. I chose one from the US because I understand that most of our listeners are from the US. But a statement that they are concerned too really got me thinking. That being said, there is still hope. Due to that residence time of CO2, it's unlikely we can do anything to fix the damage that has already done, but we can always start trying to make it better. Sea levels are going to rise. It doesn't have to eat countries. And this is where we get into the part that I think is debatable. It's what do we do about it? You can't deny that it's happening, but there needs to be discussion on what to do about it. A lot of people will jump up in your face and say, stop driving cars. We can't rely on fossil fuel like this. And they're right. But people rely on being able to drive to put food on the table for their families. I think a much more important thing is to do what you can, where you can. Maybe walk a little bit more often. Take public transportation if you can. If you can't, maybe take the elevator less. I don't know what fits best into your life. But don't deny what's happening. And better yet, don't let our leaders deny what's happening. Our society needs to start investing in cleaner energy, in things that'll help this problem to get better. When people care about things, we can move mountains. The amount of research and development it took to get computers from the 2000s to fit into our pockets as phones less than a decade later, that's unreal. I have no doubt that if we put that kind of effort as a species into dealing with this issue, we could do great things. I have no doubt about it. But when there are huge groups of people actively fighting against this goal, it makes it really hard. And that's how I'm going to end this. Write to your representatives. Protest. Try to change aspects of your lives to be better if you can. And if you can't, do those other things so that other people can put the research and development needed into cleaner sources of energy. That way, maybe in 10 years you can drive to work every day and still have no carbon footprint. But please, don't deny that this is happening. Don't turn a blind eye to it. There are a lot of people alive today who are still going to be alive to feel the pain of what we've done. And anybody being born now or in the future definitely will. So don't deny it. That's insulting. Argue about what to do, but don't deny it. I'm Tony Pearson from WHIP signing off this week's episode of Big Picture. I hope you all enjoyed it, even if the topic wasn't that uplifting. I do think it's nice to dissect individual issues and get into them a bit more, especially when they are as important as this one. Have a great week, everyone. Go out there and make a difference.